Today we're going to probably do one of the easiest factoring that will be in this whole chapter, and that is factoring trinomials that are quadratic. So quadratic means what? What degree? Degree 2. Quartic is degree 4. Degree 2. And trinomial means what? 3 terms. So when we have a 3-term, second degree, a quadratic trinomial, where a is equal to 1, so a quadratic trinomial, and I want you to circle this at these notes because Monday a is not going to equal 1, and we're going to have to do a little bit more than we have to do today. Today's the easy day. When a is equal to 1 and we have a quadratic trinomial, what is the a value? What does that mean? What other role could we give that a value? What else could we call it? It's a 2-word description of the number in front of the leading term. The leading coefficient. So when the leading coefficient of a quadratic trinomial is 1, we can follow a pretty easy process. If the quadratic trinomial can be factored, in other words, sometimes quadratic trinomials cannot be factored, but in your homework, all of those that you have assigned to you can be. So we're not going to assign you problems that you can factor because then you won't get the practice. So, but we have to make sure that we understand that not all of them can be, and often when they can be, they can be factored into 2 binomials. They will have 2 binomial factors. So if the leading coefficient a is 1, here's what we can count on. Each binomial factor will begin with the square root of the trinomial's leading term. Well, if a is 1, that would mean we're going to have something like a leading term of x squared, or maybe y squared, or maybe a squared. What's the square root of x squared? What's the square root of y squared? What would the square root of a squared be? What does square root mean? If I ask you to find the square root of something, I'm asking you to find what you're trying to find the square root of, right? You're finding that number that would be multiplied by itself to get you the thing you're finding the square root of. So what multiplied by itself would give us x squared? X. What multiplied by itself would give us y squared? Y. And what multiplied by itself would give us a squared? A. So when the leading term has a coefficient of 1, when the leading coefficient is 1, we can just find the square root of the trinomial, and that will be what each binomial factor will begin with. And then each binomial factor will end with, because binomials have 2 terms, will end with the factors of the trinomial's last term, the c value, that add up to the middle term's coefficient, which we call the b value. So does that sound familiar? Multiplies to be a number and adds up to be a different number. When did you do that? Just yesterday. That was the diamond patterns. Diamond that we did, that was its pattern, wasn't it? The 2 side numbers multiplied to be the top number, and at the same time, you could also add them together and it would give you the bottom number. Okay, so that's basically what we are going to do with these types of these quadratic trinomials. Here's an example. X squared plus 5x plus 6. By the way, circle this so that you don't forget to do this. Every time I want you to identify A, B, and C. And it's really going to be important next week. So just get in the habit today. A A equals 1, B equals 5, C equals 6. Everybody see where those come from? We've already done this, right? A, B, and C? Okay. So in the diamond method, that number that you have to multiply to be up top has to be that C value. It's the L step of FOIL. Something times something, the last times the last gives you that last term, which is the C value in this one. And they have to add up to the B value, or in other words, there should be some like terms in the middle that can be combined, and you should get the B number of that. So in this one, we have a 6 upstairs and a 5 down, and the two numbers that multiply to be 6, but yet at the same time add up to be 5 are 3 and 2. So the factored name is as simple as this. They both start with x, the square root of x squared. They end with those two numbers that you found that multiply to be c and add up to b. And why is it addition? Because both of them were positive. They were positive numbers. Multiply that back out, and I want you actually to use the FOIL method like I have set up down there. Multiply x plus 3 times x plus 2 and see what happens. Where does the multiply to get C happen in FOIL? Where does the multiplying to get C happen in FOIL? In the L step. 3 times 2, 6. Where does the getting the 5x happen in FOIL? The O step and the I step add up to 5x. So we have addition between all of these, right? So we have x squared plus 5x. 2 plus 3 is 5. And 2 times 3 is 6. It takes us back to the quadratic trinomial we were factoring. Questions? Okay, we're going to go back in the back side and we're going to practice 4 of them. After we're done with those 4, we're going to look to see what kinds of things should we be able to count on when we are factoring these so that we can come up with reasonable answers. Okay, what's A, B, and C in this trinomial? A is 1, B is 10, and C is 16. What goes where in our diamond? By the way, our diamond is just going to be an X. We're not going to finish it off and have all these fancy diamonds every time. We'll just use an X. So what's our C value? 16. And our B value? 10. So we are looking for what numbers multiply to be 16. At the same time, those numbers add up to 10. What are they? 8 and 2. Okay, 8 times 2 is 16. 8 plus 2 is 10, so we can stick a 2 and an 8 here. Does order matter there? No, because multiplication and addition are both commutative. Okay, what's the square root of x squared? X. That's what both of our binomials start with. That's the F step right there. You have to take x times x to get x squared. We have a positive 8. We have a positive 2, the O step and the I step is where the 8 plus 2 comes in. The L step is where the 8 times 2 comes in. So this is its factored name. Get rid of all my little. This is our answer. Now, go up to the side somewhere and do either the FOIL or the rectangle or whatever you do, but you are going to have to do check problems today. So you do them. I'll tell me if we're right. Did it check out for you?
Yeah.
So again, yes, today we have to do check problems. We have to check problems, okay? Okay. Let's move on to the next one. What's our first move going to be? Identify A, B, and C. I'm going to write down what A, B, and C are. Today, A is always going to be 1, but it won't always be 1 other times. So, am I right? Is A1, B negative 7, and C 6? Why is B negative 7?
It's the leading coefficient.
Yeah, because the model goes like this. AX squared plus BX plus C. So we would have changes to add the opposites. So we have plus, and it would be plus a negative 7x, wouldn't it? Okay, what's going to go at the top of our diamond? 7? Negative 7? What did I hear? 6, the C value. What's going to go at the bottom?
6.
Negative 7. So we are looking for the two numbers that multiply to be 6, but at the same time they will add up to negative 7. What are they?
Negative 6.
Negative 6, negative 1, negative 6 times negative 1, yep, that's a positive 6. Negative 6 plus a negative 1, yep, that's a negative 7. So, again, order does not matter over here, but our two numbers, our two side numbers are negative 6 and negative 1. So what would the factored name for this one be? X minus 6 times X what? Minus 1. Yeah, these are negative factors, and or negative numbers I'll call them because they're factors and their terms. These are negative numbers, so that makes it subtraction in our factors. Yes, Hale? Doesn't matter. No, you could have X minus 1 times X minus 6. That works too. Check it. Check out.
Yep.
Here's what happens when we do a check problem. When you're doing the check problem, it should, the same thing that went through your head here, what multiplies to be 6 and what adds up to negative 7, that same thing should happen in your check problem. You should be multiplying the two numbers at some point. You should be adding the two numbers at some point. So anybody say it doesn't check out? Okay, you try the next one totally on your own then. A, B, C, that's where we start. Be careful that you put the C on top and the B on the bottom. You know, it's easy to be because the B comes first. Just stick the on top and the C on the bottom. But consciously say, I have to make sure the C is on top, and then that leaves the B for the bottom. Did we have problems like this on the diamond sheet yesterday? Anybody have those out? Did we have any problems on the diamond worksheet yesterday that we had to find the two side numbers?
Yeah.
I feel like on the back side you had to do that, if not on the front side too, right? halfway down the backside, you started having to find the two numbers on the side. Okay, what are those two numbers, class?
-3 and 7.
-3 and 7, I'm hearing. Okay? So I say, multiply, do they become -21? When we add them, do they add to 4? Okay, so what's its factored name?
X plus
X plus 7, X
minus 3.
minus 3. X minus 3 times X plus 7. Order does not matter. This is its factored name. What's the hardest part about this? Some of you get stumped with those diamonds yesterday, especially on the back side. We define those two numbers. Sometimes you're like, get stuck with, I remember one yesterday, I think it was something like this. Had to multiply the 13, but yet add to, what was it? -1. I got a cheat here, and look at yours. Multiply to -13 and add up to 12. Lots of people got stuck on that one. There was another one that where 13 I thought was involved too. It was a product, I don't think so. So sometimes the hardest thing where students get stuck is right here, trying to figure out those two numbers. This is the easy part, right? Check it. Did you check it yet? Does it check out? Okay. Do you have to show check bones in your homework?
No.
Okay, let's do this last one, then we're going to start looking for patterns that we can make a summary with. Okay, what are our two numbers? Anybody got them yet?
-6 and -3 and 6.
They're the same thing.
Mm-hmm.
-6 and 3.
It's -63.
Yes.
So you get
So I feel like we're kind of
Actually, yeah.
we're having a controversy between this, right? It's
It's
either
-6 and 3. It's -6.
because they have to add up to
Negative.
-3, so it can't be those guys, can it? Okay. So our factors are
-6.
x. No, x what? -6 times x plus 3. Check it out. Okay, now I want you to start studying the 4 problems, and I want you to start making some conclusions for me. Don't tell me that, it works because -21 is -3 times 7. I don't care about how we got the factors. I want to know why should those factors seem reasonable considering what the trinomial was to begin with. Start making some observations that you think you could count on. You should be able to say to yourself, I need both numbers to be, oh wait a minute, I need one of the numbers to be and the other to be, and I'm not talking about specific numbers, I'm talking about their signs. You might want to zero in on their B's and C's also. Think you got one, Carson? Or you
No.
just, no? No? Anybody got one? Really? Tell me what happened when C was positive. Tell me something about the two numbers that we had to find when C was positive. And you might want to, kind of add in a little bit of extra information there. When C is positive, both numbers will be negative
The same.
or positive, the same, right? They have to be the same sign, don't they? Why is that?
So that they can come out positive.
Okay, because what do they have to do? If we're talking about C, they have to what? C is the product. So to get a positive product, both signs have to be the same, either both positive or both negative. So is that what happened here? When C was positive? Were both of them the same sign? They're both positive. When C was positive, were they both the same sign? They both were negative. Is that the same sign? Okay. Well then how do we know when they should be both positive or they should both be negative? How do we know that? What's going to distinguish that? Abby?
If they're both negative, B has to be negative.
If they're both negative, B has to be negative. Why is that? Where does B come from in the whole thing?
You have to add.
They have to add, don't they? That's the number they have to add to. Is a negative plus a negative a negative? Yes. So when both of them were negative, look at here, B was negative. When both of them were positive, what's B? Positive. So that's kind of a big deal. Like if you're done factoring and that's not the case, you should be like, and you're beyond checking, you're like, I'm done checking. She says I don't have to anymore, so I'm not going to. Could you at least run it through that check? And see, I better have subtraction of both of them because my C was positive and my B was negative. Or I better have addition or positive in both of them because C was positive and B was positive. I better have addition in both of them. Well, wait a minute. Now, what happens then when C is negative? So here, C is negative. Here, C is negative. What happened both times? What happened in both cases? Joe? Connor?
The signs for like B or opposite and C was
Yeah. One was positive and the other was
negative.
negative, right? Look at here. One of them is negative, the other is positive. One of them is negative, the other is positive. Why is that? Why do they have to one be negative and the other positive when C is negative? Why do they both have, why does one have to be positive and the other be negative when C is negative? Chloe? The only way to get a negative is taking a positive times a negative. So a negative, we need a positive times a negative. So one of them has to be positive, the other has to be negative when C is negative. Well, that's a good thing, but how do we know which one should be? Here, B was positive, here B was negative. So now we're going to have to figure out, well, how do we make sure that we have the right one positive and the right one negative? So let's do some summarizing on this sheet right here. This is an add-on to your notes so that you have a summary of factoring ax squared plus bx plus c when a is equal to 1.